Hi everyone, I'm excited to present LibTrack, a social reading and book discovery platform built as your final database management system project. Over the next 15 minutes, we will walk you through the problem we set out to solve, our database design, the technical implementation, and how the application works. So, let's start with a question that motivates the entire project. Where do readers go to manage their reading life? Today, most readers turn to the platform like Goodreads. But Goodreads has been owned by Amazon since 2013, meaning user data is used for commercial purposes. There is no personalized recommendation engine tied to actual reading behavior. There is no gamification to motivate consistent habits, and 55% of global readers still rely on multiple disconnected apps just to track what they read. As you can see, in the comparison table on the slide, the gap becomes clear. LibTrack offers an open catalog, a privacy-respecting architecture, multi-factor personalized recommendation, and a full gamification system with badges and a community post layer, none of which existing tools deliver in a single database-driven package. This is the gap we set out to fill. LibTrack is not just a crude application, it's a complete reading ecosystem. At its core, the system supports 9 major features areas. Readers can discover and search books with filter, import a new title via ISBN, and record their reading session and history. They can rate and review books with averages that update automatically after every submission, and receive a personalized book recommendation based on their reading profile. They can earn achievement badges, share tools with reading community through posts and comments, consult platform-wide ranking and personal analytics, and manage their profiles securely with bcrypt hashed passwords. Each of these features is backed by a real relational database, not mock data. Every database system begins with a clear understanding of requirements. Our scope covers reader management, the book catalog, personalized recommendation, review, post pages, and platform statistics. We explicitly exclude the physical library operations such as borrowing and returns. This keeps the system focused and achievable. Our target users are individual readers, reading clubs, and university students, deployed via a Streamlit web application backed by a local MySQL database. On the economic feasibility side, LibTrack uses a fully open source stack, Python, MySQL, and Streamlit, with zero licensing costs. The Open Library API is free for academic use. This makes LibTrack viable from day one, with a single developer able to maintain the code base. As shown by the Gantt chart, development was organized into 6 phases: database design, authentication, core features, recommendation and badges, testing, and UI polish. Finally, look at the need analysis table. 75% of readers borrow 0 books per month. So we build a badge and point system to drive motivation. 44% don't know what to read next. So we build recommendation engine. And at least 68% are influenced by reviews. So we build a full review and community post system. LibTrack was not designed in a vacuum. It was designed around the real reader needs.
This is our entity relationship diagram. It models 10 entities and 15 key relationships. Let me guide you through the most important ones. At the center of the model, you have the reader entity. A reader has attributes like email, password hash, preferred category, and a points counter for the gamification. The reader is connected to book through 3 separate relationships. Through BookSafe, which is a many-to-many relationship capturing a reader's reading wish list. Through Recommendation, which stores the personalized book score for that reader. And through Reviews, which stores the reader written critique and star rating. On the social side, a reader can write posts, optionally linked to a specific book. Posts can receive like and comments, each captured in dedicated relation tables. Finally, the given badges junction table connects readers to the badge catalog, recording exactly when each achievement was earned. Let's now translate this conceptual model into a concrete relational schema. Converting the ER model to a relational schema is where the database design becomes concrete. Let me highlight the most important tables. The books table uses ISBN as its primary key. This is the natural identifier for books globally. Files like average rating and review counts are updated automatically every time a review is submitted, and the others is on the slides. And now, let me prove something that's very important in the database design. Our schema satisfies BCNF. Normalization is at the heart of good relational database design. Let me walk through our BCNF proof. Recall the BCNF condition. A relation is in BCNF for every non-trivial functional dependencies X decides Y. X is a superkey of that relation. And I will take an example. First, the readers table. The only functional dependencies are reader ID determines all the other attributes, name, email, points, and so on. Since reader ID is the primary key, and therefore a superkey, this table satisfies BCNF. And we verify all 10 tables in our schema using the same approach. No table contains a partial or transitive dependencies. The schema is free from update, anomalies, and redundancies. Now that the schema is proven sound, let's look at how real transactions interact with the database. A well-designed schema is only valuable if it correctly supports real business transactions. And let me take an example of our key transactions in our system. It's submitting a review. This is the most complex transaction. We insert or update the reviews table, then immediately recalculate the book's average rating and review count using an aggregate SQL query. Both tables are updating in the same operation, and the other transactions you can see on the slides. And then let me show now you the actual SQL queries that power these transactions.
On this slide, we highlight two important SQL operations in LibTrack. The first one automatically recalculates a book average, rating, and review counts whenever a reader creates or updates a review. Instead of storing outdated rating data, the system updates the book record based on the actual rows in the reviews table. The second query checks which badges a reader has not earned yet. It compares the full badges list with the badges already assigned to the reader, so the system can clearly show both earned and logged badges. Next slide, this is our system architecture. Users interact with LibTrack through a streamlit web interface, including pages for discovery, reviews, saved books, badges, posts, and recommendations. The front end does not directly manage database logic. Instead, it calls backend Python function, and those functions communicate with the MySQL database using SQL queries. The adding new books. The system can take a ISBN, request book information from the Open Library API, extract metadata such as title, author, cover, genre, and publisher, and then store it in the database. We focus on security and data integrity. Passwords are hashed before being stored, so plaintext passwords are never saved. Registrant also validate Gmail address and enforce a stronger password format. For a session, the system uses string session states to keep track of login reader, and it clears that session data on logout. On the database side, foreign key, unique constraint, and duplicate check help prevent invalid and repeated data. SQL query also use parameterized value, which reduce the risk of SQL injection. Finally, on the next slide, explain our personalized recommendation engine. The score combines 4 signals: average rating, click popularity, saved book intent, and whatever the book genre matches the reader preferred categories. A rating has highest weight at 40% because it reflects book quality. Click saved and genre matches each contribute 20%. For example, if a fiction has a 4.0 rating, moderate click and save counts, and matches a fiction reader's preference, the score becomes 0.72. This makes the recommendation logic simple, explainable, and direct connect to the user behavior.
One of the features that make LibTrack stand out amongst other apps is our gamification system. In other words, goals that readers can achieve. Currently, we've designed badges for readers to get via recording their reading sessions, adding books to the database, etc. All the badges given to any given reader will be recorded in a separate table named Given Badges, which functions like a transactions record. Alongside the names and icons, the badges also comes with points. Well, these points don't have any functions for now, because the system may be exploited by its voluntary nature. We do hope it can provide some sense of accomplishments when readers finish their reading. Now, I'd like to walk through the actual application and explore every corner here and there. Next up, let me walk you through our system. At the start of each session, you will be greeted with a login page. If you already have an account, you can log in right away. If you don't, you will have to register in the register page. Once it's done, you can add information of the books you have in hand to the database via the book's ISBN. Then, from the discovery page, you can see the top 10 popular books decided by how many times they are being clicked or saved. For the recommendations page, it would generate recommendations for any individual readers based on their preferred genres. Then comes the profile. It displays the information of a reader. Now we can take a look at the posts page, where readers can make posts, any posts, and any given amount of posts, about their experience in reading. They can also link the post to a specific book they want to talk about. And when readers check on the post, they will be able to check on the book page for the linked book as well. Then comes the reviews page. This is different from the posts because for any reader and for any book, there can be only one review at a time. You will not be able to publish a second review for a given book. The rating from a reader will be contributed for the book's average rating that will be displayed on its detail page. Lastly, on the app page or the main page, readers will be able to see what others have posted, and they can interact with the post via liking the post or leaving a comment. In the stats page, you can see how many active readers there are, how many posts published by the community in total, how many available titles that was added via Add Books page from the community. You can also see the most active readers based on their points, which are earned via earning badges. Also, there is a top-rated books list that displays the books that have the top average rating from the community. Let's talk about the ups and downs of our system. For the former, we are confident that we've made a smooth reading experience catered towards individuals who desire more reading, as well as secure information and a vague social network to let readers feel connected. However, our system is far from complete. Many features, such as more badges, customizations can be further extended, as well as holes here and there within our system. The current data source, Open Library, doesn't guarantee complete information about desired books, or worse so, it may not include the book's information at all. Therefore, expanding our data sources is one of the major key points for future development. In conclusion, our system, LibTrack, has a complete relational database model, a personalized recommendation engine for everyone and the genre they love, posts and reviews for the community, and a full gamification system to keep the readers engaged for the system and reading as well. And that will be the end to the presentation of our system, LibTrack. I hope you had a good time, and thank you for your listening.